So what I'm going to go over now is radioactive decay, and we're going to be using something called half-life, which you guys probably learned in Earth science, may or may not remember. But when we have radioactive decay, the parent nucleus starts out and it's very unstable. And after the half-life, half the parent nucleus remains, and then half of it's been turned into what we call the daughter nucleus. So knowing the half-life, we can determine like how much material would be left after a certain period of time. And if we have a certain amount of material present, we can also figure out how old that thing is by working backwards. So I want to go over some different example problems of this to kind of help you get started on your homework. And obviously, I want to also go over the formula. So I'm going to bring up a worksheet just to show you guys, and this is not your homework, but I just want to go over a few problems I have here. And then, like I said, this will help you with your homework. So formula for half-life is A, which is the amount remaining, is equal to A naught. This is the initial amount, times 0.5, or you could write 1/2 to N, and N is the number of half-lives. So to figure out to figure out N, you could do time divided by the half-life. And obviously time and half-life would have to be in the same unit. So if one were in years, the other one would have to be in years, for example. So A and A naught can be grams. It could be fraction. It could be a percentage. So it depends on the problem. So in this particular problem, the A naught is 10 grams. So this is A naught. This is the half-life. And this is the time, at 15.2 days. So here we are finding out how much is left. So we're solving for A. So we're going to have to solve for N first. So N will equal to 15.2 divided by 3.8. And they're both in days. If they were not, you would have to convert them to the same unit. So we have 15.2 divided by 3.8. This gives us 4 half-lives. So here we would do A is equal to A naught, which is 10 grams, times, and we can either write 0.5 or 1/2. I'm going to write 0.5 here, to the 4th. And this will give us 10 times 0.5 to the 4th. This gives us 0.625 grams. And with these kind of problems, you do not have to worry about significant figures because you may get to a very, very small number. And if you're rounding for significant figures, you may get something that's not really changing very much. So I'm going to show you another way to solve this. You could solve it this way. However, sometimes, like if I forget the formula, I always remember I can just divide that 10 grams by 1/2. So if we have, for example, 10 grams after 1 half-life, we have 5 grams after 2, we have 2.5 after 3, we have 1.25, and after 4, we have 0.625. So we get the same answer either way, and you can really solve it either way, but sometimes you really have to use the formula to solve it if you have something that's not a whole number for the number of half-lives, or if you have to work backwards. So the next problem is a situation where we're kind of having to work backwards. So this problem here, medical institution requests one bismuth 214, which has a half-life of 20 minutes. How many grams of bismuth 214 must be prepared if the shipping time is 2 hours? So it's telling us that we want to have 1 gram of this when we get it, but we're going to try to figure out how much has to be present initially for this to work. So one of the first things we're going to have to do is we're going to kind of figure out what we've been given, and then in this case, we're going to also have to solve for n. So here is our A, and we have the half-life, and we have the time. So in this problem, we can start figuring out the n. So n is 2 hours. So since hours and minutes are obviously different units, we're going to make the hours into minutes to make it easier to solve. So we have 120 minutes divided by 20 minutes. And that's going to give us 6 half-lives. So now we can start plugging things in. So we have A, which is 1 gram, is equal to A naught, that is what we're looking for, times 0.5 to the 6th power. So now we can divide each side by 0.5 to the 6th power. So I'm actually going to plug that into my calculator to get what that is. So that is 0.015625. And I'm going to divide each side by that. 0.015625. When I do that, I'm going to get A naught is equal to, and that's going to be 64 grams, and that's my final answer. So lastly, I want to show you one where it's actually asking for a fraction. And like I said, you could also be asked for a percent. So here, for the next problem, it's asking us for the fraction of chromium-48 that will remain. So when we're doing one that's a fraction, what we're going to do is we're going to start with A naught is equal to 1. And when we solve, we're going to get a fraction. We're also going to use 1/2 instead of 0.5. So we have A is equal to 1 times 1/2 to the, and this is 6th power. So when we do this, we know that 2 to the 6th power is equal to 64. So A is equal to 1 times 1 over 64. So our answer here is A is equal to 1/64. So that would be our fraction, 1/64. Okay, so this hopefully will give you some ideas about some different types of situations that you will run into. And like I said, you can either use the formula I gave you, or you can divide by 2 each time. But if you run into a situation where you do not have a whole number of half-lives, you really will have to use the formula. So please email me with any questions, and I want you to try the problems on the worksheet that's on Google Classroom.